In this example, we have to solve cos of x upon 2 sine x plus cos theta equals 0, and the range is 0 degrees to 360 degrees. So we are in a pretty good place here. We've got, we're in the situation here where we've got something times something else, where the a here is a cos x and the b is a 2 sine x plus cos x. So a times b is equal to 0. So that means we're going to put the a equal to 0 and solve it, and we can put the b equal to 0 and solve it. Now, so if we do that for our solution, if we do that, we're going to have, first of all, you're going to have cos x is equal to 0, and then over here you're going to have 2 sine of x plus cos x equals 0. Now, if cos x equals 0, think of our range. Our range is from 0 to 360. So 0, 90 degrees, 180 degrees, 270 degrees, and back to 360. So cos of 90, would give you 0. So down in this place as well, cos of 270 would also give you 0. You can check that on your calculator. So that's how you can use your CAS diagram for ones like that. So here you could say that x is going to be equal to, from this thing above, x is going to be equal to 90 degrees or 270 degrees. Right, so that is part of your solution. The next part of your solution then, we're looking at this thing over here. So over here we have got 2 sine x plus cos x is equal to 0. Now this is the only situation really you would bring one of the trig functions across, because there's nothing else that you can do. You can't pull anything outside of brackets here. So here what you've got to do is bring either your sine or your cos across to the other side. So I'm going to bring my cos across to the other side. So I'm going to have 2 sine x is equal to minus cos, okay, because I have no other options here. And then what I'm going to do is I'm going to divide everything through by my cos. So the right hand side divides by cos gives me minus 1. The left hand side divides by cos, and you'll have 2 sine x over cos x, and that is the same. Remember, sine divided by cos is tan, so you've got 2 tan x is equal to minus 1, which is the same as tan x is equal to minus 1/2. Now, I could have done that a more efficient way, I'm sure, but that's the way I've done it. Okay, what we want to do is we need to find our BA, which stands for your basic angle. So how you get your basic angle is you do, on your calculator, tan to the minus 1 of 1/2. Okay, so you ignore the negative, the fact that it's a negative 1/2, that will come into play a wee bit later on. So tan to the minus 1 of 0.5, or 1/2. And when I did that on my calculator, I got 26 and I'll give 2.57 degrees to 2D piece. Now we draw our CAS diagram. So our CAS diagram looks like this: C, A, S, and T. You've got your 0, your 90 degrees, your 180 degrees, and your 270 degrees, and then your 360 degrees. Now, if we look back here, we were told that tan was negative. So tan is negative in this quadrant, S, because in the S quadrant only sine is positive, and also in this quadrant, because in this quadrant only your cos is positive. So then you put your angle. What was our angle? 26.57. Always with the horizontal line, so 26.57 degrees. 26.57 degrees. And then your first angle you're going to get from 0 round to 90. So it's 26.57 degrees shy of being 180 degrees. So we're just going to write that in. Your first answer is going to be 180 minus 26.57. That's what it's going to be. We'll work out in a wee second. And then the other one, there's 90, 180, 270. So it's 26.57 degrees shy of being 360. So that is 360 minus 26.57. And if we work those out and see what we get, let me just see, 180 minus 26.57. And that works out to be 153.43 degrees. And then the other one is going to work out to be 333.43 degrees. So your final answer, pull everything together. Remember earlier on we had the 90 and the 270. We've now got these ones. Let's put them in ascending order. So your final answer, x is equal to, so what was our lowest one? 90 degrees, then 153.43 degrees, and then 270 degrees, and then our last one there, 333.43 degrees.